Sir, Assalamu alaikum.
Walaikum assalam. Yeah, now I can hear you.
Hello, sir.
Yeah, hello, hi. Hi, Ahmed. Now I can hear you. Okay. So in this class, now we have two Sara. So one is Sara Parker and the other is Sara. What is your full name?
Sara Parveen.
Okay, fine. So I have to call you guys with your full names now if I'm going to ask any questions. Okay. Now in the last lecture here, we were doing some reactions of alcohols, right? And specifically, we were doing the reaction with hydrogen halide. Now we are going to move on to other reactions. Right, next. Now, these reactions, most of you have learned in the chapter haloalkene and halorine. Okay. So please write a reaction with phosphorus halides. So for phosphorus halide, you must have seen this reaction. Please write with me. This is the second reaction with the cleavage of CO bond. Okay, okay. Wait a second. Reaction with phosphorus halides. Okay, now please write here various phosphorus halide. Various phosphorus halide react with alcohol to form haloalkane. To form haloalkane. So there are two different types of halides. There are phosphorus trihalides and there are phosphorus pentahalides. So you can remember the reactions like this: ROH, any alcohol, when it reacts with PX3, that means trihalide, it is going to give you haloalkene plus POX3 and HX. And when you have alcohol reacting with PX5, it is going to give you RX plus H3PO3. So I hope you guys can write the answers. Please write, for example, if we have CS3, CH2, OH. If I react this with PCl5, what will be the product? If I react this with PCl3, what will be the product? If I react this with let us suppose PBr3, and what will happen if I react this with PI3? Write all the product for these four. So for PCl5, you must have written CH3, CH2, and what is the halogen here? Halogen is
Cl.
chlorine. So chlorine, very good. Plus, what will get H3PO3?
H3PO3.
Very good, Fatima. And for this one, you are going to get CH3, CH2, and chlorine plus POCl3 plus HCl. For PBr3, you are going to get 1 carbon, 2 carbon, and then you are going to have Br plus POBr3 plus HBr. Here you are going to have iodine plus POI3 plus HI. Okay, please write this down. Let me know once you're done.
Done, sir.
Done. Right, next. Reaction with thionyl chloride. सारा पार्कर आपको समझ में आ रहा है?
Yes.
Okay, great. Acha, also one more thing. Where are you from, Sara? Sara Parker, where are you from?
Bahrain.
Okay, where in Bahrain? No, sorry, not in Bahrain. Originally, where are you from?
Mumbai.
Oh, in Mumbai. In Mumbai?
Um,
Yes, Sara, where in Mumbai?
that-
That you don't know. Okay. Okay, if I tell some names, will that ring a bell? Like, will you recognize the name?
Kurla se.
Kurla. Okay, fine. Kurla. So Kurla, you will not know the detail. I think Sion and Kurla are nearby. Okay, my master's was from.
Sarah.
Sorry, Fatima. What?
I know this, Sarah.
You know this Kurla, or you know this reaction?
I know Sarah.
You know Sara. Oh,
Yeah.
how?
She's my friend. She's in the same school, and one more thing.
You both go to karate classes.
No, same school.
अच्छा, same school. I think you were thinking, what one more thing. What's one more thing?
Yeah, I only told her about this tuition.
ओके ओके. तो फिर आपने टाइमिंग बताया था क्या अपने क्लास का?
क्यों,
आई
क्या
थिंक
हुआ?
दैट इज. नहीं नहीं, आपने टाइम बताया था क्या? नहीं नहीं, मतलब इट्स फाइन, इट्स गुड दैट यू टोल्ड हर अबाउट द क्लास, बट आई थिंक सारा वांटेड टू बी इन योर क्लास, आई गेस. इज दैट राइट, सारा पार्कर?
हाँ.
हाँ, दैट्स राइट. Because generally ऐसा नहीं होता, because Sara was having the trial class in some other batch, but then again today I got a call that can we shift her to this class. I mean, I think she can do, I mean, because we were in the middle of alcohol chapters, right? That is why. अच्छा, चलिए ठीक है. So both of you are from Indian school, right?
Yes. Yes.
है ना, Indian school. ठीक है, कुछ याद है? Otherwise I usually forget these things. School का नाम. Okay, right, next. Alcohols react with SOCl2 to form chloroalkane. Chloroalkane, comma, sulfur dioxide, SO2 gas, and HCl gas. Okay, see, this is one of those reactions in which I have also written the byproduct. That means the byproduct are important. And if you remember from the chapter halocane halorine, you will also remember why it is important. Because SO2 and HCl, these are gases, they will evaporate. Okay, that means they are going to be escape. Yes, they're going to escape from the container, and we will get pure chloroalkane. We'll have ROH plus SOCl2, giving you RCl plus SO2, which will escape out, and HCl gas, which will also escape out. We can write some more examples. So 2 carbons and then chlorine. So Sarah Parker is your title. Huh, Sarah? I'm asking, Parker is your title.
Surname.
Surname. Okay. Like, where does it originate from? Any idea? Because in Mumbai. Yeah, tell me. I'm just interested.
Konkan side, Ratnagiri.
Konkan side and Ratnagiri side.
हाँ.
Oh, okay, fine. Parker. I hope everyone is done. Now, let's move on to the next topic. Okay. And this topic is very important. Acidic dehydration of alcohol. That is the third reaction. Now, all of these previous first, second, and third reaction you must have seen in the chapter haloalkane, haloalkane. Now, write the fourth one, acidic dehydration. Right here, alcohols undergo dehydration. Dehydration means removal of water molecule, removal of H2O to form alkenes. To form alkenes in the presence of a protic acid. What are protic acid? For example, H2SO4, comma H3PO4. Okay, H3PO4. These are examples of what protic acid. Okay, there are other options also. For example, we can also use HCl. Okay, but that HCl is not going to give you acidic dehydration. That is going to give you substitution, because we have their chlorine negative, which is going to act as a nucleophile and get attack on the OH, and it can remove the OH and form what? Haloalkane. So we use protic acid in which the counter anion, for example, in H2SO4, it will dissociate into H plus and SO4 2 negative. H3PO4 is going to dissociate into H plus and PO4 2 negative, right? PO4 3 negative. Now, all of these things why we have to consider, because if the counter anion is very large, it is not going to attack on the nucleophile. It is going to be stabilized. So these counter ions are very stable. SO4 2 negative, PO4 3 negative, these are very stable. But Cl negative is not very much stable because of its small size in comparison to SO4 2 negative and H3PO4. Okay, so Cl negative attacks, but these are not going to attack on the alcohol. Now, write the reaction. Also, one more thing is very important. At 443 Kelvin. Okay, now if you have alcohol, this alcohol should contain a beta hydrogen. Okay, each of these carbon will contain 4 bonds. One of the bond will be with carbon and carbon. The other will be something else. But this beta, this is your OH. So this is your alpha carbon. This is your beta carbon. Now this beta carbon should have a hydrogen. It should have a hydrogen. Otherwise, this reaction is not going to happen. And in the presence of H plus coming from H2SO4 or H3PO4, we are going to get an alkene. What is going to happen? Removal of water. This is going to be removed, and we are going to get C double bond C, and the rest 2 bonds are as it is, plus H2O. Okay. So what are the bonds breaking? So I can say that CH breaks, COH breaks, and what forms? Pi forms. Okay. Write this down. Let me know once you're done. Then we are going to look at the mechanism. Sorry.
Done, sir.
Done. Now write the mechanism. Okay. So we'll see the mechanism of ethanol to ethene. CH3, CH2, OH. In the presence of H2SO4, it is going to give you, and one hydrogen will be removed from the, from the alpha carbon, OH will be removed, from the beta carbon, hydrogen will be removed. Okay. So CH2, one hydrogen is removed from beta carbon. So from CH3, it is now CH2. Double bond will be formed, and this CH2, because OH has been removed. Okay, plus what we will get? Water molecule. We are going to look at the mechanism for this. Please write the step 1. Okay. Right here, step 1. Protonation of alcohol. Okay, so we have the first step, 2 carbon atoms, oxygen, and 1 hydrogen. These are the lone pairs. Plus we have H plus from the H2SO4. Now we have the electron source on the oxygen lone pair electron. It is going to attack on the H plus, leading to formation of 2 OH bonds and a positive charge on oxygen atom and a positive charge on oxygen atom. The next step is the formation of carbocation. Right, next. Step 2. Formation of carbocation. Now we have 2 carbon atoms, and then we have oxygen with 2 hydrogens attached to it and a positive charge. Now the electron will move from sigma bond to this positive charge, and water will be removed. Now we are going to get what? CH3, single bond, CH2 positive plus H2O. Now once the carbocation has been formed, write the step 3. Elimination of proton. So this has 3 hydrogens, single bond, 2 hydrogens as a and a positive charge. Okay. अच्छा, अब देखिए यहाँ पे generally क्या होता है ना, we have this proton, it is going to give the electrons here like this, and it is going to get removed, leading to formation of C two hydrogens, double bond, and here also two hydrogens. Okay, generally it is reversible because this process is what it is, single step only. And as soon as it gives electron, what will happen? It will form a double bond. Now, obviously, when you have a charged species, and here you are not having any charges. So obviously, the one which is having no charges is more stable, and that is why the reaction, though it is reversible, it is favored towards the forward direction. It is favored towards the forward direction, and what we are going to get? We are going to get H plus as a byproduct. Wait a second. Plus H plus. Okay. So this mechanism is important. It can come in your examination also. Write this down. Done, guys? Yes or no? Please tell me.
Done, sir.
Okay. Right remarks. There is another one point. Acidic dehydration of alcohol. Acidic dehydration of alcohols to alkene occurs via intermediate carbocation. Next, stability of carbocation follows the order 3 degree is most stable, followed by 2 degree and followed by 1 degree. I hope all of you remember this. Right, next. Hence the ease of dehydration. Hence the ease of dehydration also follows the same order. Three-degree alcohol is most easily dehydrated, followed by 2 degree alcohol and followed by 1 degree alcohol. Okay, this is important. Please remember this. Right, next point. Since dehydration of two-degree and 3 degree alcohols is easy, they are done at milder conditions. Okay, so if I have alcohol like this, I will get 85% H3PO4 and at 440 Kelvin. Okay, an alkene here like this. OH. And this can be done if you have 3-degree alcohol. This can be done even in 20% alcohol, sorry, 20% H3PO4 at even milder condition around 360, but exactly 358 Kelvin, and you are going to get double bond CH2. I hope all of you have revised Setzef rule. याद है लास्ट क्लास में हमने बोला था? हाँ, फातिमा, अहमद, सारा, वाफिया. Sarah as in Sarah Parveen, not Sarah Parker. Obviously, she was not present. And Rehan, were you present in the last lecture? Yes, Rehan. You
Yes,
remember I said you were present in the last lecture, right?
yeah,
Do you remember I asked to revise the Setzef rule?
yes, sir.
Okay. So right next. Dehydration of (2-degree and 3-degree alcohol always occur according to Setzef's rule. Okay. Write the first question. So we have a 2-degree alcohol, okay? And see, what is the alpha carbon? You have to first of all identify the carbon, which is directly bonded to what? Which is directly bonded to OH group. So alpha carbon is this carbon, alpha. Now what is beta carbon? Beta carbon is the adjacent carbon. So this is the beta carbon. Oh my God, what color is this? This is the beta carbon as well as this is the beta carbon. Now, what is removed from alpha? Alpha से क्या remove करते हैं? OH. And what do we remove from beta? We remove hydrogen from beta. And we make the double bond between alpha carbon and the beta carbon. Okay. So now what is going to be the major product here if I'm going to react this with any acid? Let me see how many of you guys remember this. H2SO4 with some heat. I'm going to get either this product or I'm going to get this product. A and B. Chaliye. Send the answer in chat, which is the major product, A or B. चलिए और हम सवाल दे देते हैं, ठीक है ना? A और B. Okay, write the answer for these two. Razan, correct for both the cases. Fatima, what happened? आप नहीं याद करके आई हैं? Set the rule. Revise नहीं किया था आपने? Yes, Fatima. Okay, Fatima, ये first का answer है या second का? वो देख लीजिए. Ahmed, correct, very good. For both. ऐसे कैसे for both? Okay. Fatima, please turn your mic on. हाँ, चलिए. So, yes, Fatima, tell me which beta carbon, beta 1 or beta 2? Or why beta 2? I mean, you have, sorry, you have opted for beta 2. Why beta 2? Why is A? Why is this major? Fatima, what is the Setzeff rule? What does it say? Tell me, what does it say? अरे है क्या हो गया? What type of alkene must be formed? What type of alkene must be formed, Fatima? The major alkene will be. सारा आप बताइए. सारा परवीन. The major alkene should be what? कैसे पता लगाते हैं?
Substituted.
More substituted, right? So it is having this first A1. It was having how many alkyl groups? It has 1 and 2 alkyl groups. This one, it is only having 1 alkyl group. Now that is why this is having 2 alkyl groups. That is why it is going to be major. Now looking at this part, A and B. Now let's look at the first case A. It is having only 1 alkyl group. Here it is having 1 alkyl group, 2 alkyl group, and 3 alkyl group. So this will be major here. Now it is correct, Fatima. Okay. So the alkene with more number of substitution, or the alkene with more substituted double bond, is always major. Okay. Right. Next, as dehydration occurs via occurs via carbocation, rearrangement can take place. Okay. Okay. Now see what kind of rearrangement can take place. See. Ari bachao. Just a second, guys. My cousin is disturbing me. Ari bachao. Okay, guys, listen. OH. Okay, and we have a alkyl group here. Okay. Now, in the first step, what is going to happen? H plus is here. It is going to attack like this. And we are going to get hydrogen, hydrogen, and a positive charge. And then a alkyl group here. Okay. Now, the next thing what can happen here, this particular is going to, the oxygen atom that is bonded with 2 hydrogen, it is going to be removed, leaving out water molecule. And I will be getting here CH2 positive. Okay. CH2 positive. Chaliye. Now flip some pages. Okay. Those guys who have done halocene and halorine with me, shift some pages and tell me what kind of shift will happen here. Hydride shift or alkyl, hydride shift or methyl shift. Okay. Flip some pages back. अभी कुछ दिन पहले ही हमने आपसे ये सवाल किया था. So I hope you remember this. Flip some pages back and tell me what kind of shift is going to take place, whether it will be hydride shift or it will be methyl shift. लास्ट टाइम आई थिंक रजान आपने आंसर दिया था ना? यस रजान, कौन सा शिफ्ट होगा? है ना? अब भूल गए आप? 2-3 में भूल गए? जल्दी बताइए कौन सा शिफ्ट होगा यहाँ पे? हाइड्राइड शिफ्ट और मिथाइल शिफ्ट?
Hydride shift.
Correct, Fatima. Okay. We'll have hydride shift like this. Okay, hydrogen is going to attack here. And this will become CH3. This bond is like this. Now this carbon which has given its hydrogen, it will get a positive charge. Okay. Now you have to see. Now this is your alpha carbon. Okay. This red carbon is now your alpha carbon. And then you have the beta. This is beta 1, beta 2, and beta 3. So obviously you can see that beta 2 and beta 3 are almost similar. And we will get more substituted alkene if I make a double bond with, tell me what, beta 1 or beta 2 or beta 3. कहाँ से मिलेगा हमको सबसे ज़्यादा substitution? If I will make a double bond with, tell me guys.
Beta 1.
Very good. Okay, so this will be your major product. एक similar example लिख लीजिए. OH. Okay. Oh, wait a second. Rather write the OH here. Okay. This means we have a CH3 group here. We have a CH3 group here. And in the presence of H plus, this is going to attack here, leading to formation of OH2 positive. This bond is going to break. Wait a second. After this, you are going to get a carbocation. Can you guys hear anything? Yes, Fatima, tell me.
Some light voices.
Some light voices there, no?
समझ में नहीं आ रहा क्या बात करते तो.
No, I mean, it's fine because these are kids. Even if you understand, these are just here very much curious how I teach and they want to learn 12th standard chemistry. Ask her to leave. Her name is Ariba. Can you please tell Ariba to leave, Fatima? Okay. Now, what kind of shift is going to happen here, guys? We are going to shift here. The shift will be methyl shift. So this methyl is going to shift here, leading to the formation of positive charge like this. Now, this is my new alpha. Okay, and I think you can see that the beta is going to be this one. Okay, and also wait a second, not that. Like this. Is everyone done? Yes or no? Please tell me.
Yes, sir.
Okay, right next oxidation. Okay, right next oxidation. सारा पार्कर must be thinking ये कैसी क्लास है ना, बच्चे आके यहाँ पे चिल्ला चिल्ली करके चले जा रहे हैं. But usually it is not like this, Sara Parker. Okay, you have to bear with me till what date, Fatima? Do you remember? Yes, Fatima.
Okay.
Till what date? Yes, Fatima. What?
No, sir, I don't remember.
Remember the date. 16th. I think somebody said right. 16th. Okay, till 16th of November.
So
Right
when
next.
did you say this?
When? Sorry, what, Fatima?
When did you say this? I don't remember.
No one remembers. Razan, Sara, Parveen, Wafia. Do you guys remember this?
Yes,
I said
sir.
that you will have. Yeah, I said this. You will have 1 hour lecture. Okay, till 16th of November, and you might get some disturbance here and there. But I make sure that there is minimum like जैसे वेस्पर थ्योरी में होता है ना मिनिमम रिपल्शन, वैसे ही try to have minimum disturbances. Okay, right next, the oxidation of alcohol involves the cleavage of OH and CH bonds and formation of C double bond O double bond. Okay, so what is the structure of alcohol? So in alcohol we have carbon with some bonds like this, and with oxygen and hydrogen OH bond, and then we have hydrogen here like this. Okay, so this bond here it is going to get broken, and this bond here it is going to get broken. That means carbon is losing a sigma bond, oxygen is also losing a sigma bond, and both of these are going to make double bond O. That is structure आपका trigonal planar होता है, so it will be something like this. Okay, so please write these reaction are also called dehydrogenation reaction. Okay, because hydrogen is getting removed from here. Okay. Right, next. The formation of product depends on type of alcohol. That means whether you are having 1 degree or 2 degree or 3 degree alcohol, and the oxidizing agent. Right, next. The oxidizing agent that we majorly use are, please write, oxidizing agents. All of these are what? Strong oxidizing agents. Okay. So first of all, right, aqueous or alcoholic or acidic KMnO4. Right, second, acidified K2Cr2O7 or Na2Cr2O7. Third, nitric acid, HNO3. Fourth, chromic acid. H2Cr2O7. Okay. Then we are going to look at these different oxidizing agents in the next class, and how like what are the products given by 1 degree alcohol, product given by 2 degree alcohol, and what kind of product is given by 3 degree alcohol. Okay, write this down, let me know once you're done, and then we'll end the class. Okay. Okay, please let me know once you're done. Done, sir. Done. What about others? Sara, Parveen, Sara Parker, Razan, Wafia, Fatima, Rehan.
Yes,
Rehan, you're done?
Done, sir.
Done. Sara, you start. Do I have your number, Sara, or do you have my number?
No.
No, na?
No.
Okay. So please message me on this number. Okay. Sorry. 17530998007. Note this number down, or you can just ask Fatima also and get my number. Okay. And once you get my number, and just remind me that I have to send you the previous lectures. Okay. या फिर आपको सब चीज सारा से, sorry, फातिमा से भी मिल सकती है.